Imagine the universe as a vast, dark ocean. For eons it remained cold and empty. Then, something incredible happened. Light. The first stars flickered into existence, piercing the darkness like cosmic lighthouses. These brilliant giants were not merely points of light, they were the universe waking up. They were the seeds of everything we know and see around us. The birth of a star is a truly awe-inspiring event. It is a story of gravity, energy, and the transformation of matter on a grand scale. From the cold, dark clouds of gas and dust, stars ignite, flooding the cosmos with light and warmth. They are the engines of creation, the lifeblood of the universe. Stars are born from massive clouds of gas and dust, known as nebulae. These nebulae drift through the vast expanse of space, silent giants waiting for their moment of creation. Gravity is the driving force behind a star's birth. It draws the gas and dust particles together, pulling them closer and closer. As gravity pulls the material inward, the cloud begins to collapse in on itself. This collapse causes the cloud to spin, much like a figure skater pulling their arms in to spin faster. The spinning cloud flattens into a disk, with a dense, hot core forming at the center. This hot, dense core is the protostar, the earliest stage of a star's life. Deep within the heart of a protostar, temperatures and pressures soar to unimaginable levels. This intense environment triggers the most important process in a star's life: nuclear fusion. Fusion is the process where hydrogen atoms, the simplest and most abundant element in the universe, are forced together under immense pressure. They fuse, creating helium, and releasing a tremendous amount of energy. This energy, radiating outward from the star's core, is what causes the star to shine. The outward pressure from fusion balances the inward pull of gravity, creating a delicate equilibrium that defines a star's life. This balance can last for millions, billions, or even trillions of years, depending on the star's size. Stars come in a dazzling array of sizes and colors, each one a unique beacon in the vast expanse of the universe. Some stars are small and faint, barely visible to the naked eye, while others are true giants, dwarfing our own sun by many times. These colossal stars can be hundreds or even thousands of times larger than the sun. The color of a star is a fascinating clue that tells us about its temperature. By observing the hue of a star, astronomers can determine whether it is burning hot or relatively cool. Cooler stars, which have lower surface temperatures, glow with a reddish hue. In contrast, the hottest stars shine with a brilliant blue-white light, indicating their intense heat. Our sun, a yellow star, falls somewhere in between. It has a moderate temperature, which gives it its characteristic yellow color. This balance allows it to sustain life on Earth. A star's life cycle is determined by its mass. The mass of a star dictates how it will live and die, shaping its journey from birth to death. Massive stars live fast and die young, burning through their fuel quickly in a blaze of glory. These stars often end their lives in spectacular supernova explosions, scattering their elements across the cosmos. Smaller stars, like our sun, are more frugal. They sip their fuel slowly, allowing them to live for billions of years. This slow and steady consumption of fuel ensures a long and stable life. When a star eventually exhausts its fuel, it enters the final stages of its life. For many stars, this means a dramatic end, often culminating in a spectacular supernova explosion. These explosions are not just the end of a star's life but also the beginning of new cosmic phenomena, as the remnants can form new stars, planets, and even black holes. Stars are not just beautiful points of light, they are cosmic factories, forging the elements that make up everything we know. The process of nuclear fusion within stars creates heavier elements from lighter ones. Hydrogen fuses into helium, helium into carbon, and so on, creating the building blocks of planets, people. Section 6. Shaping the cosmos, stars and the structure of galaxies. Stars are not randomly scattered throughout the universe. They are gathered together in vast collections called galaxies. Our own galaxy, the Milky Way, contains hundreds of billions of stars, all orbiting a central point. The gravity of stars helps to hold galaxies together, shaping their structure and influencing their evolution. Stars are also responsible for the beautiful spiral arms we see in many galaxies. These arms are formed by density waves that travel through the galaxy's disk, triggering bursts of star formation as they pass. Without stars, galaxies would be vastly different places, lacking the structure and beauty we observe. Section 7. Echoes of the Big Bang, the first stars. The first stars to form after the Big Bang were very different from the stars we see today. These primordial stars, often referred to as population 3 stars, were the first to light up the cosmos. Unlike the stars we are familiar with, which contain a mix of elements, these early stars were composed almost entirely of hydrogen and helium, the simplest and most abundant elements created in the Big Bang. They were massive, short-lived giants composed almost entirely of hydrogen and helium, the simplest elements in the universe. These stars were incredibly hot and bright, burning through their fuel at a rapid pace. Because of their massive size, they had very short lifespans, often only a few million years, compared to the billions of years that stars like our Sun can live. These first stars played a crucial role in the evolution of the early universe. Their formation marked the end of the cosmic dark ages, a period after the Big Bang when the universe was devoid of any light sources. As these stars ignited, they began to illuminate the cosmos, bringing light to the vast, dark expanse. Their intense radiation ionized the surrounding gas, a process known as reionization, which cleared the way for the formation of galaxies. This reionization was a critical phase transition in the universe, transforming it from a neutral state to an ionized one, allowing light to travel freely through space and enabling the formation of complex structures. They also seeded the universe with heavier elements, paving the way for the formation of stars like our Sun and planets like Earth. Through the process of nuclear fusion, these stars created heavier elements such as carbon, oxygen, and iron, which were then dispersed into space when the stars exploded as supernovae. These elements are the building blocks of planets and life as we know it. Studying these early stars helps us to understand the conditions in the early universe and how galaxies first formed. By observing the light from distant galaxies and using advanced simulations, astronomers can piece together the history of the universe, shedding light on the processes that led to the formation of the first stars and the subsequent evolution of galaxies. Section 8. A Cosmic Dance, the Cycle of Star Birth and Death. The life and death of stars is a continuous cycle. The material ejected into space by dying stars, enriched with heavy elements, eventually becomes part of new stars and planets. This cycle of stellar birth, life and death is essential for the evolution of galaxies and the universe as a whole. It ensures that the universe is constantly being enriched with heavier elements, creating the diversity of matter we see around us. This ongoing cycle is a testament to the interconnectedness of the cosmos, where death gives way to new life and the universe is forever renewed. Section 9. Decoding the Universe. Stars as Cosmic Storytellers. Stars are more than just beautiful objects in the night sky. They are ancient beacons, each one a luminous storyteller narrating the grand tale of the cosmos. When we gaze up at the stars, we are looking back in time, witnessing the light that has traveled across vast distances to reach us. They are cosmic storytellers, their light carrying information about their age, composition, and distance. Each twinkle and shimmer is a message from the past, revealing secrets about the universe's formation and evolution. The colors of the stars, from the cool reds to the blazing blues, tell us about their temperatures and the elements they contain. By studying starlight, astronomers can piece together the history of the universe from the Big Bang to the present day. The light from distant stars and galaxies acts as a time capsule, allowing scientists to understand the conditions of the early universe and the processes that have shaped it over billions of years. Stars help us understand the fundamental laws of physics, the processes that govern the evolution of galaxies, and the origins of the elements that make up our world. Through the study of stars, we have learned about nuclear fusion, the life cycles of celestial bodies, and the cosmic events that lead to the creation of new stars and planets. They remind us that we are part of something much larger than ourselves, connected to the vast cosmos by the very matter that makes up our being. The atoms in our bodies were forged in the hearts of stars, linking us to the universe in a profound and intimate way. This connection inspires a sense of wonder and curiosity, driving us to explore and understand the cosmos. As we continue to explore the universe, stars will undoubtedly continue to illuminate our understanding of the cosmos and our place within it. They are not just distant points of light, but key players in the ongoing story of the universe. Each discovery we make about the stars brings us one step closer to unraveling the mysteries of the cosmos and understanding our own origins.